All right, I am back. We're about to continue. Raise your hand if you're able to hear me clearly. Okay. All right, so that's good enough. Now, we had started drug calculation. We looked at exact concentration. We look at exact concentration for percentage solution. And now we're going to look at exact concentration for ratio type solution. So sometimes the solution is written as a ratio. For instance, the epi that you're required to give for anaphylaxis is a 1 in 1,000 solution. So you need to know what that represents. So if you have a solution with a ratio that is 2 in 1,000, what that means is there is 2 milligrams of that medication in 1,000 microliters of fluid. Right? So if you have a 2 in 1,000 solution, it means that you have 2 milligrams of the medication in 1,000 microliters of solution. And that would be the same as 2 milligrams per mil. That would be the exact concentration. 2 milligrams per mil. So 2 in 1,000 is the same as 2 milligram in 1,000 microliter, which is the same as 2 milligrams per mil. You can have a solution with a ratio of 2 in 10,000. If you have a ratio of 2 in 10,000, it means you have 2 milligrams in 10,000 microliters of fluid, which is the same as 2 milligrams in 10 mils. And the exact concentration would be 0.2 milligrams per mil. So again, if you have a solution which is 2 in 10,000, like the epinephrine that is given in cardiac arrest, which is a medication you will not be required to give. I'm just using it as an example. So the cardiac arrest epinephrine is 1 in 10,000. Right? No, so if you have a ratio of 2 in 10,000, all it simply means is you have 2 milligrams in 10,000 microliters of fluid, and 10,000 microliters of fluid is the same as 10 mils. So it's actually 2 milligrams in 10 mils. And if we use the exact concentration formula, it's 2 milligrams divided by 10. You're dividing, the point moves to the left. So it's 0.2 milligrams per mil. Classwork. What is the exact concentration for a 3 in 1,000 solution and a 3 in 10,000 solution? Work that out quickly. Give me the answer for both, for the 3 in 1,000 and the 3 in 10,000. You cannot have a point without a 0 before it. So you cannot leave off the 0, or else your answer will be marked incorrect. Can be 0.3 mil. It must be 0.3 milligrams per mil. All right, so that is straightforward. 3 in 1,000 solution is 3 milligrams in 1,000 microliter, which is the same as 3 milligrams per mil. 3 in 10,000 solution is the same as 3 milligrams in 10,000 microliter, which is the same as 3 milligrams in 10 mils. And the exact concentration would be 0.3 milligrams per mil for the 3 in 10,000. All right, now let's move on to formula number 2. Now, you may be required to draw up a medication from a vial or an ampule, and you need to be able to work out how much fluid will represent the dosage. So you need to know to work out what we call the volume of a drug to be given. So that is the desired dose, the dose you're supposed to give, times the available volume, how much fluid is available, divided by the amount of drug you have. Now, you have to be able to identify what is your desired dose, what is the available volume, how much of the drug you have present. So let's look at example 1. So example 1 says, give 2 milligrams of a 8 milligram in 4 mil solution. So let's make sure that we understand. Let's ensure that we understand what the question is asking. So you have a 8 milligram in 4 mil solution. So you have 4 mils of a solution or 4 mils of fluid that has 8 milligrams of a drug inside of it. We need to give 2 milligrams of that drug. So we need to work out how much mils we would pull up to give us that 2 milligrams. And using the formula, it is the desired dose times the available volume. And the dose that we supposed to give is the desired dose. So the desired dose is 2 milligrams. The available volume, which is the available fluid, is 4 mils. So it's 2 milligrams times 4 mils. And then you divide that by the amount of drug you have. We have 8 milligrams. Why do I feel like I've done this with you guys before? Have I done this before? I'm having deja vu moments right now. Have I ever gone through this with you guys? Why some people saying yes and some saying no? Have I done this part already? Feel like I've done it before. Okay then. The level of inconsistencies. Anyway, let us continue. All right, so we have a solution that has 8 milligrams in 4 mils. We need to give 2 milligrams. Using the volume of a drug to be given formula, it is the desired dose times the available volume divided by the amount of drug you have. The desired dose is 2 milligrams. The available volume of fluid is 4 mils. So it's 2 milligrams times 4 mils, and the available drug is 8 milligrams. So it's 2 milligrams times 4 mils divided by 8 milligrams. Now, when you have a problem like this, milligrams will cancel out milligrams. So milligrams will cancel out milligrams, so your answer can only be in mils. Right? So 2 4s is 8. 8 divided by 8 is 1. So we would draw up 1 mil of the 4 mil solution to give 2 milligrams. That's example 1. Example 2, And remember to zoom in on your side if you're not seeing clearly. Example 2, you have a 10 milligram in 2 ml solution, and you need to give 2 milligrams, right? So give 2 milligrams of a 10 milligram in 2 ml solution. The desired dose is what you're supposed to give. The available volume is the amount of fluid you have available, and the amount of drug is how much of the drug is available. So following the formula, it would be 2 milligrams times 2 mils divided by 10 milligrams. Milligrams will cancel out milligrams, so your answer can only be in mils. So that's 2 times 2, that's 4, divided by 10. Point is moving to the left, so it's 0.4 mils. So we would drop 0.4 mils of the 2 mil solution, and that would be the 2 milligrams that we give the patient. The next question is class work. So you have 100 milligrams of a 250 milligram per 5 mil solution. Sorry, give 100 milligrams. How many mils would that be? Show working. So don't just put 2 mils. How did you get to the 2 mils? Show working. Right, so one to the other people them in the group. I don't have all day to sit down and wait for you people to answer a question, you know. I need you to answer the question that I can move on to the next thing. Show you're working. How did you come to that answer? So what is your desired dose? What are you multiplying that by? And what are you dividing with? Right? That must be shown in your drug sheet. So if that don't show, you're not going to get the full marks. I'm not even going to mark the question. Right? Okay. So the desired dose is 100 milligram. The available volume is 5 mils. And the amount of drug available is 250 milligrams. So it's 100 milligrams times 5 mils divided by 250 milligrams. Milligrams will cancel out milligram, so your answer can only be in mils. And that would be 2 mils. All right, next one. You have give 200 milligrams of a 250 milligram per 5 mil solution. So give 200 milligram of a 250 milligram per 5 mil solution. Work that out. You people, some of them don't listen very well, you know, and y'all need to listen and pay attention. I said, show your working, Mr. Mackenzie and Mr. Jones. Show your working. All right, so the desired dose would be 200 milligram. That's what we need to give the patient. The available volume is 5 mils. And the amount of drug that we have would be 250 milligrams. So based on the formula, desired dose times volume divided by the amount of drug we have, it would be 200 milligrams times 5 mils divided by 250 milligrams. Milligram will cancel milligrams. And if you work out the question, you're going to end up with 4 mils. So 4 mils is what we would drop to give the 200 milligrams of the medication. All right, now let's move on to volume of fluid to be given. So we just look at the volume of a drug to be given. Let's look at the volume of fluid to be given. All right. Now, when we talk about volume of a fluid to be given, it's how much fluid we are going to give the patient over a specific period of time. Now, when it comes to fluid resuscitation, you can administer bolus medication or fluid, and you can administer fluid over a controlled period or an extended period of time, right? Volume infusion. So volume of fluid to be given is the volume to be given times the drip set divided by the time in minutes. Now, when we're giving fluids, you can use the bolus approach, where bolus mean you give it one time, right? So bolus mean you're giving the fluid one time, or you're giving the medication one time, right? Infusion mean it is being given over an extended period of time. So you have the bolus, you can give fluid as a bolus. You can use the 3-to-1 rule. And the 3-to-1 rule means that for every mil or every liter of blood that the patient loses, you will give 3 times that amount. So that's what it means. Again, let me repeat that. For the 3-to-1 rule with fluid administration, it means that for every 3 mils or every 3 liter of blood the patient loses, we will give 3 times that amount. So if you have a patient that you suspect has lost 1,000 mils or 1 liter of blood, how much fluid would you give based on the 3-to-1 rule? Quickly, let's not drag it out. Right, pretty straightforward. If the patient loses 2 mils or 2 liter, if a patient loses 2,000 mils or 2 liter, how much fluid would we give using the 3-to-1 rule? All right, so you can use that rule, the 3-to-1, or you can use the others. Now, when it comes to IV access and fluid resuscitation, that's the only thing I'm teaching you regarding IV access. So an IV access is indicated if you need to prevent a vein from collapsing, meaning you need to keep a vein open. You need to give a medication, which is not something you will be doing as an EMT. or if you need to do fluid resuscitation. So that's really what the focus is going to be on, fluid resuscitation. Now, the other rule is you give fluid based on the patient's body weight. So the body weight rule is you give 20 to 30 mils per kilogram for adults and 5 to 10 mils per kilogram for pediatric patients. All right. Now, you have different types of drip sets that we use to give fluids. You have your micro drip set and you have your macro drip set. So micro would be 30 to 60 drops per mil. That's a micro drip set. And what it means is if it's a 30 to 60 drop per mil set, it means that it takes 30 to 60 drops with that set to give you 1 mil. That's what it means. So if it's a 30 to 60 drop mil per set, it takes 30 to 60 drops to give you a mil with that set. Now, micro drip set is used for controlled volume infusion. So when we're doing controlled volume infusion, it's micro drip set. Or if you need to keep a vein open, you can use a micro drip set. Can do it with a macro too, but yeah, you can use a micro drip set. The macro drip set is used for shock or fluid resuscitation, right? And the macro would be 10, 15, or 20 drops per mil. So macro is for shock, micro is for medication and controlled fluid administration. The number represents the amount of drops that would give you a mil for that set. Now, what you need to learn here, make sure you learn that part here now. If I am using a 30 drop or a 60 drop set, if I want to know how many drops per second, I simply use the value of the drip set to divide 60, right? So if I want to know how many drops I would get per second with a 30 drop set, I would simply divide 60 by 30. So it takes 2 drops to give me a second. We need to know it down to a second because that's how we adjust the drip rate. All of this information is important for you to be able to work out volume administration. So you must be familiar with how you're going to give the fluid, whether it's via bolus, 3-to-1, or weight base, and you must be familiar with the drip set that you're using. And we use macro for fluid resuscitation. All right, now let's look at example 1. So example 1 states you have a 160-pound patient. So a 160-pound patient requires fluid for resuscitation at 20 mils per kilogram using a 10 drop per mil set. You are required to give the first 1,000 mil as a bolus. So you're going to give the first 1,000 mil one time, and the remaining fluid must be infused over an hour. Now, the first thing that we need to do is to convert the pounds to kilogram. And there are 2 ways you can do that. Whichever you decide is fine by me. So you can use a calculator or you can simply use the rule of 10. Whichever one you're comfortable with, I have no issues. This is the part of the drug calculation that you need a calculator. So I ain't gonna kill you for that. So we have a 160-pound patient. Using the rule of 10, divide 160 by 2. That gives you 80. Then find 10% of that 80, which is 8. And then subtract that from 100, which gives us 72. 72 is less than 75, so we round it down to 70. It's easier to work with zeros when giving fluids. Right? So the patient is 70 kilograms. If you don't understand the rule of 10, simply divide 160 by 2.2, and that will give you the answer in kilograms. Whatever you get, round it off to the nearest tenth. So we have a 70 kilogram patient, and we need to give 20 mils per kilogram, right? So we need to work out now how much fluid the patient needs in totality. So that's 70 kilogram times 20 mils per kilogram. Kilogram will cancel out kilogram, so you have mils. 2 zeros, put down your 2 zeros, 2 sevens, 14. So the patient must get 1,400 mils. The question says you are to give 1,000 as a bolus. So subtract 1,000 from the 1,400 mils. That gives you 400 mils remaining. So you're giving 1,000 as a bolus, and then 400 mils must be given over 1 hour. So using the formula for volume infusion, it is the volume to be administered times the drip set divided by the time in minutes. So that's 400 mils times 10 drops per mil. It's 1 hour, that's 60 minutes. So it's 4 mils times 10 drops per mil divided by 60 minutes. And that would give you 60.6, which we would round that off to 67. You can't give 0.6 drops, so 67 drops. And to find out how many drops per second, just divide that by 60, which would give you 1 drop per second when you round it off. No. Don't I have a question? Why did I think I had a question? So let me backtrack now. So let me change up stuff a little bit. So this is your question to see if you understood any of this. I'm sure someone are lost. Someone are gone a bush right now. Right? So this is the question. You have a patient that weighs 100, and you have a patient that weighs 180 pounds, 180 pounds, and you need to give fluid resuscitation at 20 mils per kilogram. Give the first 1,000 mils as a bolus, and then give the remaining portion over an hour. What is your drip rate per minute? Didn't say per second, I say drip rate per minute. Work that out. If you want me to repeat the question, raise your hand. Okay. So this is the question. Let me use my whiteboard. Let's see if you people have learned anything now. So this is the question, right? Text. Patient, oops, I need black. Come on. So the patient weighs 180, sorry, 180 pounds, right? 180 pounds. You need to give 20 mils per kilogram using a macro drip set at 10 drops per mil, right? 180 pounds, 20 mils per kilogram for the fluid resuscitation drip set, macro drip set, 10 drops per mil. So I want you to first work out, this is what I want you to work out first. How much fluid would you give this patient initially? So how much fluid would you give the patient initially? That's the first thing. Work out how much fluid. So work out how much fluid you're going to give the patient first. Let's work that out first. Anybody have the answer yet in terms of how much fluid this patient requires? Shouldn't be taking so long for that. He's 180 pounds. We need to give fluids at 20 mils per kilogram. How much fluid would this patient be required to get? For the last time, people, show working. Right? You people are testing my patience, you know. Right? And I test my patience. Show working. So I need to know you got to 1,600 mils. Okay. All right. Okay. All right. So the patient would require 1,600 mils. So using the rule of 10 or the 2.2 rule, you're gonna convert 180 pounds to kilograms. So you divide 180 by 2.2, you get 81, you round it off to 80, multiply that by 20 mils per kilogram. So 80 kilograms times 20 mils per kilogram would give you 1,600 mils. 1,000 is to be given as a bolus, and 600 mils is to be given over an hour using your macro drip set. What would be the drip rate per minute? Using the volume to be administered formula, which is volume to be administered times the drip set divided by the time in minutes. How many drips per minute? Or how many drops, I should say. not drips. How many drops per minute? Show working. Taking too long, people. Use the formula. Use your calculator. What is the answer? How many drops per minute? I said 1,000 is to be given as a bolus. The remaining portion is given over an hour using a macro drip set at 10 drops per mil. What is your drip rate per minute? Okay. All right. All right. So I see one response. Anybody else? If you're present. So your response is noted, Miss Carr. Anybody else? Not sure what you're asking me to go back over, Miss Beckford. All right, I see Miss Barnes' response. Okay. Your response is noted, Miss Barnes. Anybody else? We have 29 people in the class. What do you mean by second, Miss Barnes, Mr. Robinson? You're gonna put your second, Miss Barnes, on your drug sheet? When I send you that drug sheet, you're gonna put your second, Miss Barnes, on it? When I have you in the classroom face to face, you're gonna tell me your second, Miss Barnes? Okay. All right. All right. So that's all right. I'm seeing some consistency. All right. So if you're using the formula for volume administration or infusion, it is the volume to be administered, right? We have 1,600. 1,000 is given as a bolus. So we subtract that 1,000 from the 1,600, and that would leave 600 mils remaining. We need to give that 600 mils over an hour. So it is 600 mils times the drip set that we are using. So it's 600 times 10. We need to give it over an hour. 1 hour is 60 minutes. So it's 600 times 10 divided by 60, right? 600 mils times 10 drops per mil divided by 60. That would give you 100 drops per minute. Now, if I am giving 100 drops per minute, how many drops per second? How many drops per second? Waiting for that answer. How many drops per second? Shouldn't be taking that long. Why are we taking so long with that? How many drops per second? I'm not seeing any measurement on your response, Mr. Thomas, so that's incorrect. If there is no measurement on your response, it is incorrect. And don't tell me 1.6. How did you get 1.6, Mr. Allison? All right, so let me make sure I write out this one. Pencil. So first thing you do is 180. You people clearly don't understand what the statement means to show working. It don't look like you people understand standard English or something. On a slow or what? Show working. What is so difficult in that to understand? You cannot give 1.6 drops per second. It has to be round off. Two mils per second, 1.6 mil. That's incorrect, Mr. Roberts. And that's why I need to show how to work out the thing. Your measurement is incorrect. Right? All right. It can't be 1.6 mil per second. It must be drop per second. Must be drop per second. So 180 pounds divided by 2.2 give you, give you 81. And you round that off to 80. Right? Then 80 kilogram multiply by 20 mil per kilogram. That would give you 1,600 mil. Then subtract 1,600. I'm writing it out that persons can see it and at least have an example to work with. 1,600 mil other than the one that is on the drug calculation form minus 1,000 mil as bolus. Right, that's gonna equal to 600 mil. Then using your formula, it is 600 mils times 10 drops per mil divided by 60 minutes. That's going to equal to 100 drops per minute. Okay. And if we bring that down to seconds, it is 100 drops per minute divided by 60 seconds. And that's going to give us 1.666. So we can't give 1.6 drops, it's closer to 2. So just round it off to 2 drops per second. That would be the answer. Let me see if I can enlarge it. Okay. So get rid of that, get rid of this, get rid of this. Bring this up. Bring that. All right. Bring this up. Bring this up. All right. Oops. I think that should be visible. All right. Let me. All right. So that has been recorded. So when you go back to the recording, you can look on that. Let me stop the recording now.